We want to show f of x equals 2x over the quantity x squared plus 4 is eventually decreasing. Let's remember from Calculus 1, if f prime of x is less than 0, then f of x is decreasing. So we'll start by finding the derivative of f of x. So f prime of x, using the quotient rule, is the bottom function x squared plus 4 times the derivative of the top, which is 2, minus the top function 2x times the derivative of the bottom, 2x, all over the bottom squared, x squared plus 4 as a quantity squared. Now I'm going to go ahead and distribute. I have 2x squared plus 8 minus 4x squared over x squared plus 4 squared. And that's going to leave me with 8 minus 2x squared over x squared plus 4 squared. I can factor out a 2. From the top, I'll have 4 minus x squared over x squared plus 4 quantity squared. And 4 minus x squared factors to 2 minus x, 2 plus x, all over the quantity x squared plus 4 squared. So we quickly went through a derivative, and what we want to do is find where the derivative is equal to 0 or potentially undefined so that we could find the critical values. And so here, the denominator is always positive, so this will never be undefined. The two critical values are going to be positive 2 and negative 2 if we set each of the factors in the numerator equal to 0. So we have two critical values, x equals negative 2 and x equals positive 2. And so what we would do from here is if we wanted to find all the intervals where f of x is decreasing, we would start to break up our domain at the critical values. The domain of this function, since the denominator is always positive, is going to be all real numbers. So we would think about the different intervals, like negative infinity to negative 2, negative 2 to 2, and 2 to infinity. And we'd pick test points in each interval and substitute those into f prime of x to determine whether f prime is positive or negative. But we can actually shorten this work a bit because we want to determine if f of x is eventually decreasing. So what we could really do is just focus on this interval from 2 to infinity. And so I can pick a test point value. So I could pick a test value in the interval from 2 to infinity. So let's say x equals 3. And we'll substitute that into the derivative function to determine if the derivative is positive or negative. Because as we know, if the derivative is less than 0 or negative, then f of x will be decreasing. So we're going to look for the sign of that derivative, f prime of x. So we can substitute 3 into any version of the derivative. I'm going to pick the most simplified version down here. As I said, the denominator is always positive. The numerator, this first factor, 2 minus x, if I plug in 3, 2 minus 3, that's negative, and 2 plus 3 is positive. So a negative times a positive is a negative. So the sign of f prime on this interval is negative. So what that means is that f is decreasing on the interval, on the x interval from 2 to infinity, or when x values are greater than 2. So we have shown that f of x is eventually decreasing. All right, let's do this one more time. Show y equals x times e to the negative x squared is eventually decreasing. So once again, we're going to need the derivative, this time y prime, and this is going to be a product rule with a chain rule. So I'm going to leave that first function alone, x, times the derivative of e to the negative x squared. So e to the negative x squared times negative 2x, that's the chain rule, plus e to the negative x squared times the derivative of x is just 1. So now I'm going to look at these two terms here and recognize that I could factor out an e to the negative x squared, and I'd be left with this x and this negative 2x, so that's negative 2x squared, and then plus 1. And I'm going to rewrite this as 1 minus 2x squared over e to the x squared. So here is my simplified derivative. I want to go ahead and find out where this is potentially equal to 0 or undefined to find my critical values. The denominator cannot equal 0, so this can't be undefined, so I'm just going to set that numerator equal to 0. So I'm going to solve 1 minus 2x squared equals 0. So 1 equals 2x squared, 1/2 equals x squared. So if I solve for x, I'm going to get plus or minus 1 over radical 2. So I'm going to get two different critical values. And again, I want to determine that this is eventually decreasing. So I can think about, splitting up the domain again and my possible 3 intervals. But really, I just want to show that after 1 over radical 2, that I'm decreasing on that final interval. So I'm just going to test this interval, 1 over rad 2 to infinity. So I'm going to pick a test point, test value in this interval. So 1 would work. So if I pick x equals 1 as my test value, and I substitute that into my derivative function. So if I substitute it in here, I'm going to get 1 minus 2, because I just have 1 squared, and that's a negative. And again, the bottom's always positive. So f prime is less than 0 or negative on that interval. So f is decreasing eventually. So from 1 over radical 2 to infinity. And so we can write x in that interval, or x values greater than 1 over rad 2. Of course, that's rad 2 over 2 if you want to rationalize. But we have shown using derivatives that eventually f is decreasing.